Hi there, students. Welcome back to geometry. This is Mrs. Brunk, and today we're going to be beginning Module 10. In Module 10, we're going to be continuing looking at the quadrilaterals, the different types of four-sided figures that we studied in the prior module. But today we're going to explore some of the properties of quadrilaterals a little deeper through proving the slope criteria for parallel lines. So our learning goal is we will be able to prove sides of parallelograms are parallel using the slope formula, and we'll be able to use, to find the missing coordinate of a parallelogram. So we're going to focus on the parallelograms, and we're going to be proving that the parts are parallel, the opposite sides. So the slope criteria for parallel lines theorem says this: two non-vertical lines are parallel if and only if they have the same slope. So we studied that back when we looked at writing equations for parallel and perpendicular lines in an earlier module. So in order to have a pair of parallel lines in a quadrilateral, those lines would have to have the same slope. And you could verify that they had the same slope if they existed in the coordinate plane. So example 1 says show that the figure is the given type of quadrilateral. So this particular one, rather than proving it's a parallelogram, we're going to prove it's a trapezoid. And remember, to be a trapezoid, you just have to have one pair of parallel sides. And so looking at this drawing, it appears that AB and DC are parallel. So if we want to know that for sure, we would have to calculate the slope. So let's remember how we calculate slope. So first of all, there's a slope formula. So that's y2 minus y1 over x2 minus x1. So in order to use the slope formula, we would have to know the coordinates. So for instance, the coordinate of point A is negative 1, 1, and the coordinate of point B is 2, 3. And so we could then use those coordinates, and we take the y coordinates and we'd subtract them. So that would go on the top, to keep the y's on the rise, right? So the y2, it doesn't matter which one you call the second point. Let's say you want to say that's the second point, and this is the first. Then your y2 would be 3, so it'd be 3 minus 1. And then your x2 would be the 2, so that's 2 minus negative 1. So that would be 3 minus 1, which is 2, over 2 minus negative 1, which is really 2 plus 1, and that's 3. So the slope would be 2/3. So the slope of the one line is 2/3. That's AB. So oops, I guess I should have labeled that as AB. Yep, AB's slope, right? And then if I wanted to do the exact same thing, I could do that also for DC. But there's another way to find slope if you've already got the figure graphed. And remember, that's by using rise and run. So that's what I'm going to do here. So let's say I started at point D, and I wanted to rise and run. So I could see what I want to run. Let's see, I'd have to go 1, 2, 3, 4, 5, 6. I'd have to run positive 6, right? And I'd have to rise 1, 2, 3, 4. I'd rise positive 4, which means my rise is positive 4, my run is positive 6, and that reduces to 2/3. So that's if I wanted to use the graph to find the slope of CD. So whichever way you decide, or if you want to do one way and one the other like I did, that's fine too, as long as we can see that we have a pair of parallel sides. And so we have a trapezoid then. So now we've confirmed that this is in fact a trapezoid because we have that one pair of parallel sides. So in B, we want to do the same kind of thing as far as verifying, but this time we want to verify it's a parallelogram. So that means we should have two pair of parallel sides. So what we're going to be looking at are these pair of opposite sides. So it means we got to calculate the slope of PQ and of SR and see if they're the same. So again, however you decide you want to do it, if you want to do the counting. So let's see, PQ, I'd have to run 1, 2, 3, 4, and then rise -2. So I run 4 and rise -2. So it's -2 over 4, which makes -1/2 when I reduce it. You always want to reduce your slopes down to lowest terms. And then SR, I'm going to have to rise -2 and run 1, 2, 3, 4. So that's -2 over 4. That makes my slope -1/2. So just exactly the same as the other one. So we've got a pair of parallel sides there. Oops, let's see. We've got this pair, so we at least have a trapezoid there. So now we're going to go ahead and see if we can do the same thing, and I'm going to change colors here. And we're going to try to find PS and QR. So PS, QR. Again, you can also use slope if you want to do that. But again, that would just involve having to, identify the coordinates. So I'll do that on one of them just to practice that again. So P is at -3, 1, 2, 3, 4. So that's -3, 4. And then S is at -1, 0. So calculating the slope, we do the y2 minus y1, so that's 4 minus 0. And then on the bottom, we got x2 minus x1, -3 minus -1, which would be 4 over -2, and that's -2 for a slope. And we'll do the same thing with the other one, but this one I think I'll count the slope. So I'd have to rise, let's see, we'll go run, there's 2, and then rise 1, 2, 3, -4. So that's -4 rise, +2 run, and that slope is -2. And so since you have both pair of opposite sides parallel, because they have the same slope, we've verified that, we can tell that PQ and SR are parallel. We can tell that PS and QR are parallel. And that means that PQRS must be a parallelogram. And so we've checked that off our list. So now it's time for a couple of you try questions. So I want you to try C and D. C asks you to show that this is a trapezoid, so it should be pretty obvious which sides you're going to check to make sure are parallel. And then the next one is show that it's a parallelogram. So go ahead and pause the video now and verify in C and D that they are the indicated quadrilateral. Pause the video now. Okay, so thank you for giving those two a try. In C, I chose to use the two different methods. On JK, I used the slope formula and identified the coordinates, and I got 2 over -6, which reduces down to -1/3. And then with ML, I just used the rise over run, and I had to rise a -1 and run +3. Which gave me a -1/3 slope. That's why it's really important to make sure that you're reducing your slopes to lowest terms. Otherwise, we might not recognize that these two have the same slope had we not reduced the 2 over -6 to -1/3. So we can verify that this is a trapezoid. And in D, I had to verify both opposite pairs being parallel. So looking at AD and BC, those were both a -2 slope. And again, just this particular one, I just used the counting the rise and run. When they're graphed, that's that's pretty much the easiest way. That way you don't also get caught up worrying about, like, when you're using the formula, the y2 minus y1 x over x2 minus x1, you might be, like, say, subtracting a negative and forget that that means you change that to addition, or maybe you forget and put the x's on the top instead of keeping the y's on the rise. So anyway, and then AB and DC were also parallel because they both had the slope of 3/2. Okay, so in these next questions, our task is to find the coordinates of the missing vertex in each parallelogram. So these are going to be parallelograms, but they're only going to give you 3 coordinates, and we have to, using what we know about parallelograms, which means opposite sides parallel, and being parallel, having the same slope, we'll use that to figure out the missing vertices. So let's first plot the ones they give us. So they gave us A, B, and D, and they want us to find C. So let's see, A is at 1, -2. So 1, -2 would be right there, and that's A. B is at -2, 3. -2, 1, 2, 3 is B. D is at 5, -1. 5, -1, which is here. And that means that the other coordinate's going to be somewhere up in here, right? We know that because of, in order to make a quadrilateral, and also being a parallelogram, it's going to have to be in that area. So probably what I think is the easiest way to figure out where this other coordinate is to figure out, like, what the slope is between 2 of the points. So for instance, let's say I looked between A and D. In order to go from A to D, I have to go up 1, and then 1, 2, 3, 4 to the right. So I had to go up 1 and 4 to the right to get that. So actually I'm going to draw on the rest of this parallelogram here, the sides. So this is one of the sides, this is one of the sides, and we just need to know where C is so we can draw the rest, right? So if you do that same thing, you can figure out, in fact, where that other point is. So, like, just think about if you did the exact same thing that we just did with A. So let's see if that would work. So if we went up 1 and right 4, so if we went up 1 and right 4, we'd be here, okay, right? So up 1 and right 4, that would put C right here. Let me just kind of scope out and see what that would look like. Now, does that look like a parallelogram? Sure does, right? So basically all I did was I took what this slope was between the points A and D, and I repeated that. So I just rose 1, oops, let's use a different color. I rose 1, and I ran 1, 2, 3, 4, oops, 4, to get to that point, which, by the way, is at 2, 1, 2, 3, 4, 2, 4. And then when I connect them, now that creates what appears to be a parallelogram. And we know for sure that those 2 opposite sides have to be parallel because I used the same slope of 1, oops, of up 1, rise 1, run 4, so that would be a 1/4 slope, right? And the other 2 sides would also be parallel, because if you look at going from, say, B to A, 1, 2, 3, 4, 5, 5 down, and 1, 2, 3 to the right, right? So that would be -5/3, and then 1, 2, 3 to the right, and 1, 2, 3, 4, 5 down. So we could tell that the other pair of sides are parallel as well. So this is the answer I was looking for is, where's the coordinate for C? It's at 2, 4. It's really just graphing the points that you have and then just using the concept of rise over run for slope to locate the other point. Let's try another one, and then we'll have you test out your understanding with a you try question. So P is at -3, 0. So let's see, -3, 0, which is right there, right? Q is at -2, 4. So -2, 4, 1, 2, 3, 4. There's Q. 2, 2 is R. And they want us to figure out where, let's see, P, Q, R, S. So we're looking for what S is. So our final answer should be a coordinate that identifies where S is. Okay? So first of all, I would kind of get an idea of approximately where it's at. So it's obviously got to be somewhere right around in here, right? And so I'm going to connect the points that I do have with segments. Just get a better idea. And then what I could do is, again, use this idea of slope. So I could just say, okay, say I'm going from P to Q. I'd have to go up 1, 2, 3, 4, and right 1. Right? I'd have to go up 4 and right 1. So that's a slope of 4. So if I did the exact same thing here, but instead I have to go back, I'm going to go down to the other one, so I'm going to have to go in the exact opposite direction though. I'd have to go left 1, oops, hold on. I'd have to go left 1, left 1, and down 1, 2, 3, 4. So in order, then I'm going to make both slopes, or both rise and run negative, which still makes a positive slope, right? But just so that I can locate where that new point is, and it would have to be right here, and that definitely looks like it makes sense. If I connect, you can see that looks like parallelogram, yep. So it, because the point, what I probably should have done is maybe started at Q, because I knew I was going to have to go down further. So I should have thought about it like going from Q to P, so then I would be going left 1 and down 4. And then the same thing here is left 1 and down 4 to get our new point at S. So that coordinate is at 1, -2. And again, you may want to quick check that the other pair of sides are parallel, but they did tell you that these 3 points created a parallelogram if you found that 4th point. So, but just to check it, I could tell that I'd have to go 1, 2, let's see, 3, 4 to the right and down 2. And then for the other one, I'd have to go down 2 and 1, 2, 3, 4 to the right. So you can tell that the other pair of sides is parallel as well. Okay, so I'm going to go ahead and have you try C as a you try question. And then we'll save D as maybe an in-class you try. So I'm going to have you try C and then tune back in and check to see how you did. And then we'll wrap it up and we'll plan to maybe revisit using D as maybe a warm-up question when we meet in class. So pause the video now and try question C, locating the missing vertice to make a parallelogram. All right, so thanks for giving that one a try. So looking at the points that were given, I chose J and K. I mean, you could have also done this a different way. You could have chosen J and M and then used that slope to generate the new coordinate. But I chose between J and K, and I knew I had to rise 3 and run 3 to get to K. So I did the same thing. Starting at M, I rose 3 and ran 3 and located my new point. Especially since you have the graph here, it's very kind of visually intuitive whether you got the right point and you're doing the right, slope. But again, you could have done starting with J and go to M, so I could have gone down 1 and 1, 2, 3, 4. So down 1 and right 4. So then for this one, I'd go down 1 and right 1, 2, 3, 4. And it would still have given me the exact same position for the point L, which is at 4, 0. So that actually does it for today's class, and we'll go ahead and maybe use D in some capacity when I see you in class. So thanks for coming. Have a good day.